Okay.
And you can see
Does it show
this.
names?
Nope.
Oh.
So this pie chart,
That's a cool pie chart.
it is.
It's got a lot of different colors.
I like this piece of pie right there for you.
Yeah, that's the right answer, isn't it?
Perfect piece.
Well,
Kind of piece.
I like that size of piece of pie.
No, that orange one's
I don't eat pie.
What's wrong with you?
Well, I just never had pie. Like,
Peach pie? Apple
my
pie?
family never eats
Oreo
pie, so
pie.
I don't eat pie.
You
No,
use-
he also doesn't eat pasta. He does
I
not
can't
like
eat noodles.
And he does not like
It's a
noodles
texture
at all.
thing.
Dude,
Ramen
noodles are
noodles are
good.
I can't
Yeah,
eat
like tuna Alfredo.
Well, the pie thing gets me. I don't care about the noodles. The pie thing.
I've eaten chocolate pie.
So that's good.
It was like a chocolate Oreo pie.
It was
So
good, wasn't it?
I hated it.
Yeah.
Rhubarb pie?
That's my favorite, strawberry rhubarb.
Strawberry
I'll
rhubarb.
eat that all day, every day.
I'll eat waffles every day.
Okay. It's kind of like a pie.
Oh my god, is that gonna be
Brown waffle.
Like this right here.
Okay, guys, we started out last Tuesday talking about what would be an ideal gas. And an ideal gas has to follow those 5 statements of what's called a KMT. All it does is says that spaces between particles are large compared to the size of the atom. That's one of them. So gases have to have large spaces between the particles for an ideal gas. Second thing is there's no attraction between the particles. So there'll be no attraction between particles. They are able to float freely without any resistance to their movement. Okay? Their collisions are perfectly elastic, which means there's no loss of energy. And always leave one out, because I'm thinking here. And then the average kinetic energy is equal to the temperature, or proportional to temperature. That's not the one I was thinking of. And they're always in constant motion. Always in rapid, fast motion. Does that make sense? So, which of these 3 would probably put you in a position where you would have, or 4, would have a gas that would have those high temperatures? Yep, high temperatures. That makes sense? Because the particles are going to spread out. They're going to move faster. There's definitely not going to be much attraction between them when they're moving past each other at a fast speed. So that's the one we want to focus on. Got a lot of different answers there. Hopefully that you understand that concept a little bit better now. Okay. Being that said, which of these statements are false according to kinetic molecular theory? Collisions are elastic. That's not false. Large spaces between very small particles. That's not false. That's what's in there. The attraction between the particles. We don't want attraction between particles. We have no attraction. So 33.3%, or a third of you answered that would be a false statement because we don't want attraction between particles. And in the green here, particles are moving very fast. That's a positive. So the only one on there is attraction between particles. Does that make sense?
Yeah.
Okay.
Yeah, that was right.
All right. Next one, we got a bigger piece of the pie, which is good. What's that an example of? When we look at when they slow down, that means that the temperature is lowering. Okay? So that's lowering, and that creates a situation where it might not be gas any longer, right? Because if it slows up enough, it's going to go probably to a liquid, and we get condensation. Or if it might go to a solid if it's deposition. Make sense? Okay. Because it can get cold enough to do that. Next one, biggest piece of the pie is good there. The size of the box is volume. So space taken up by... Now, I can see how pressure can be affected by that. But that's kind of an effect of the volume getting smaller. Pressure going up. Okay, so. All right. We got one more before we do problems. What happens to the container when the number of molecules decreased by 1/2? And we went over that little worksheet. It kind of had all the drawings in there, and we went through that, if you remember. And if you cut them in half, then the pressure's cut in half. So big piece of pie. You guys did really well on that, and the majority of it. Now the problem. There's a bunch of answers because there's This is involving the other class too. So I didn't say not to use units, and they use units. But the answer is what? So you guys are supposed to use one digit.
I just put 2.
You guys put. See, that's why we could have maybe one peak if you guys would have used one digit. So the answer's 2. Did you guys get it?
Yeah.
What'd you round it to?
Yeah, 10.
Yeah, you might look at your calculation because.
It was like 2.
I got 2.5.
Oh, you got 2 point. Yeah, it's going to be really close to 2. So the setup, you guys look at your paper to see the setup. It should be 2.5 times 0.0821 times 303 divided by 30. What's that?
I didn't know what's wrong. I didn't see it.
Right. Oh, 0.15? Yeah, you can do that. It probably won't affect the answer.
Yeah.
Oh.
Okay. Now, next one. The answer is 8.5. Okay, you guys did a lot better, and we didn't. We had a bunch of answers for that. So 8.5. So the setup for that would have been 0.35 times 0.0821 times 223 divided by 0.75. Okay? Last one, we got a lot more wrong answers on the last one. Let's see if we get. This one's 253.
I just put 254.
That's fine. 253, 254. Do you notice that comes up a lot? 253, 253K, 253.7K. Okay? Yep.
What was the equation of this? Is that in-
Right. So,
Well, I put
so the equation for this one
That's my
that you would have
Well, I don't know. I got
I don't know what I wrote the other side down. Yeah, I
You
divided.
know what? It's in Messenger.
Yeah.
It says disabling no open as Messenger divided by. But
But
I should save your contact. I just see like 9.229 or something.
You get 3.125 divided by 0.
And I'm like, oh, it's no left for ginger.
So in this one, it would have been temperature.
Oh yeah. Move that. You see that video that second dog that the guy grabbed on the highway?
You got like
this jack
I got
all
5.
over forward. Guy driving the same damn dog and they're prone for their
Okay, what's the top number after the end?
And you just
Okay, so PV equals nRT. So we're solving for T. So then we divide both sides by nR.
Yeah. And then it's PV over NR.
So then 1.25
I had to clean
atmospheres.
2.5.
That's 2.5 liters.
Yeah.
Oh.
Divided by 1.15 divided by 0.0821.
Oh, so you bring it. Okay, I know.
So then that's 253.
It's like when you take X and get it by itself.
Yeah,
Okay.
I know what I did wrong.
All right.
I bring it over to get it.
So we'll go back to the next ones. You guys will probably get a lot of these right. But that's the setup. Did you get that set up?
Yes.
Sometimes students make mistakes because what they'll go is they'll go multiply, divide, and then they'll like multiply by the bottom. You gotta divide. You gotta divide. Press equal divide. Yeah.
or something's not.
Depends upon your mode of operation that you
Unless
use
it's
to get through.
it's what's wrong.
Okay.
You work that
Which of the following represents melting? You guys all know that. Solid to liquid.
100%?
Which of the following represents freezing? Everybody got that. Liquid to solid.
Those
Oh,
questions were
let's go.
hard.
Sublimation, you guys still don't know much about that yet, but that's from a solid to a gas, which would be the blue. Some of you guys go gas to solid. Gas to solid is deposition.
Liquid to gas?
Solid to gas.
This one, sublimation,
Just liquid to gas?
No.
solid to gas. Gas to a liquid described, that would be condensation. And liquid describes, liquid to a gas described what's in the following, that would be evaporation.
Wait, what was
Sublimation,
Solid to gas.
solid to gas.
See, okay, I was confused, because how does that happen?
Well,
Dry ice.
Dry ice.
what happened, yeah, dry ice would be an example.
Oh.
Yep, dry ice would be an example. Okay, last thing want guys talk about is in your binder there's some things I'll have you look at.